From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 313, recorded live Thursday, April 12th, 2012. Support for Hansel Minutes is provided by Telerik, offering the best in developer tools and support. Online at telerik.com. In this episode, Scott talks with Nathanael Jones about image resizing and scaling with ASP.NET and IIS.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. And today I'm talking to Nathanael Jones. He runs imageresizing.net. He's got a really great application and module that you can pop into your ASP.NET application to make image resizing simpler. And I recently did a blog post on called Back to Basics, talking about HTTP modules and servers. And as with all great things on my blog, the great things are in the comments. I think that the comments that Nathanael put in were much more interesting than my post itself, so I wanted to have you on the show. Thanks for chatting with me.
Thank you, Scott. It's an honor to be here.
Oh, my pleasure. So we were just talking actually before we started the show, and you immediately kind of launched into some really interesting information. You said that most of the image resizing code on the net is just kind of copy-pasted, and it might be wrong.
It's unfortunate and true, because there's been a lot of really good coders write a lot of blog articles about image resizing, probably more like 75 to 90 articles. I still haven't found one that wasn't buggy in some way. The best article out there is one that actually doesn't encode JPEGs at 90 quality instead of 100 quality, for example, which will give you really big file sizes. It's not really web appropriate. Because the difference between, say, 90 and 100, it's not visually perceptible, especially on, in a web browser. If you take a magnifying glass to it, you'd have to have really sharp lines in there to be able to tell a difference.
I did a blog post where I was encoding some graphics on the fly. I would basically make a bitmap and make an image, and then I saved it. I said bitmap.save, response.outputstream, and I went to PNG, and you made a really great comment in the comments. I still need to update the blog post that I was doing that wrong.
The GDI PNG encoder requires a seekable stream most of the time. I believe that for a simple enough sequence of, line art, for example, it doesn't actually seek, or else the seek is small enough that it never gets through the buffer. It actually has to seek on the underlying stream, because those streams are wrapped in an interface which has a buffer between COM and .NET. So, for a really small PNG, you won't have to see a problem, because it'll either be small enough to fit in that buffer or simple enough that the compression never even has to really kick in, basically a runtime length encoding scenario. But for like photographic PNG, you really have to have a seekable stream, which means you have to write to a memory stream, seek back to byte 1, and then write that memory stream back to the output stream, because the ASP.NET response stream, it doesn't support seeking, even in .NET 4.
I see. So I was saying graphics from image. I was drawing onto the graphics object, and then I just said save to output stream. So that was like a write only. You can only go forward on an output stream because you're streaming that out to the browser. And that works with JPEGs because you can do that in one pass. But you're saying PNGs need to move forward and backward in order to do that.
Right.
Is that right? Do they need to move forward and backward, or they just need to go to the beginning again? Is it a two-pass operation?
It depends on the implementation. There's a lot of different ways to encode PNGs. Some are more efficient, some are less efficient. I'm not sure what GDI's algorithm is. It's not really exactly documented.
Yeah, Bertrand Leroy's got some really great articles where he talks about the different ways to do JPEG and PNG encoding on the server side. I've noticed internally at Microsoft, we still haven't kind of got official support for using system.drawing in a web context, and there's all sorts of warnings on MSDN that say you shouldn't do this and you shouldn't do that.
I honestly don't expect that support to ever arrive because of the amount of pitfalls there are with it. You can use system.drawing in a perfect manner, but you're definitely not going to achieve that by copying and pasting code. Even encoder parameters and Yeah, so that's why. I mean, if you can't, it's so complicated and difficult, error-prone to use system.drawing that there's no way Microsoft could support it, in my opinion. I believe the official statement is that WPF isn't supported either on the server. And unlike system.drawing, that requires full trust. The only drawing API I know of that Microsoft still supports is WIC, which is only available, the server-safe version is only available on Windows Server 2008 Release 2 and up. Because that's the version that's free-threaded, that's server-safe. And, you have to work through a COM interface to do that. But you do get great performance.
Well, but help me understand this. I mean, many, many, many years ago, 10 years ago, when .NET first started out, I was doing banking software and I was processing check images on the server side. And we did this for years. Never had a problem. And I have no doubt that the listeners are kind of thinking, well, I'm using system.drawing and I'm using the graphics context and making images dynamically. Millions of people are doing that. What are the pitfalls and when would we see them? Because to hear that it's totally unsupported and not something we should do, but everyone's doing it anyway and it probably will work is a kind of a confusing thing to reconcile.
Oh, and that's a big topic. There was a clarification article. I don't know if I linked to it on your blog or not, but it explained that it's not that it won't work and it's not that it won't be stable. It's just that you won't get support if you call Microsoft. And that's what it comes down to. Is it's one of those things, that's one of those situations, those cans of worms that are not Microsoft deems not worth trying to support. Mm-hmm. So if you're generating imagery, there's fewer pitfalls than say if you're loading a 10 megapixel camera image and processing it. You're dealing with a lot less memory. Megapixels matter because when you decompress a 500 kilobyte JPEG, it might be 50 megabytes in memory. And to decompress it, you have to allocate all that contiguous amount of space. So if you are not handling your memory management properly, then, 50 megabytes, per image decode, that can stack up really fast. And, then the biggest problem with using system.drawing is that garbage collection is not implemented. When I say not implemented, I mean that the .NET, the CLR, it doesn't know how big those images are. A bitmap to the CLR, it's 1 or 2 kilobytes. If you got a lot of metadata, maybe, 100 kilobytes. Mm-hmm. It's a tiny little object. It's, the size of a big string. It's not on the high priority list for disposal. So you can have, if, much smaller objects are getting garbage collected first, those 50 megabyte objects will just stay around forever, especially under high load. There's to dispose or not to dispose, that's 1 gigabyte question, often referenced blog post on that issue. Maybe we can add a list of links or something next to the
Absolutely.
podcast.
If you have a list of valuable links or things that people need to see, then we'll add them all to the show notes. So
basically, if you aren't putting your GDI object in a using clause, it's not going to get disposed reliably. And calling .dispose on it is also not reliable because GDI has a lot of different exceptions. It'll just happen for lots of reasons, like running out of memory. You can't control all the situations in which GDI will throw an exception. Say a user uploads an image which is corrupt, and, you have an exception before the .dispose line. That isn't going to get garbage collected. And so it's really critical that you either place your dispose statements in using clauses by using a using clause or putting them in a try finally block. Because, in a bad scenario, you're going to have exceptions, and those exceptions are going to trigger more exceptions because you're now going to be having a memory leak. So it's really critical. Don't call .dispose, use a finally block or a using clause. And that's everything in system.drawing, which implements iDisposable, like encoder parameters, image attributes, stuff that acts like a structure, yet it's actually allocating unmanaged memory. It's unlikely that it'll cause a server crash as quickly as not disposing a bitmap or image instance, but it's still subject to the same problems with garbage collection.
So are you saying that we should use the using, which says try catch finally, and we should never call dispose directly? Or are you saying we shouldn't use a using?
If you nest using clauses, that works too. But sometimes you need your code flows such a way you need a little more control, like checking if it's null before disposing it. And so you can do that in a try finally. Just make sure that you nest your inside a finally block. If you dispose one object, that dispose call can fail. So make sure inside that's another try finally block. And inside that finally block is the next dispose statement.
I see. So you're really saying that when you start doing this kind of work, particularly around loading images, you can't trust anything. You should be as defensive a coder as you can be.
Absolutely. And on top of this, assuming the garbage collection did work properly, consistency and throughput is a lot more important on a server than response time for a single request. And what I mean by that is, manual memory management should be applied even if you have automatic memory management in your language when you're dealing with large objects like this. For example, resizing a standard compact camera JPEG, 10 megapixel. You're allocating, probably about 40 megabytes of RAM to load the image. And say we're resizing it to 5 megapixels. And so we're going to need 20 megapixels of space allocated for that, 20 megabytes. So you end up with 60 megabytes of space, plus any temporary buffers you need. So a single request can use a lot of RAM, and it's important that you dispose that as early as possible. Waiting for garbage collection to do its thing is just a really bad idea if you want consistency. And
because now that might sound like a lot of RAM, but it kind of swells up, it does its work, and then it goes away. I mean, it is okay for the CPU to do work, right? That's what it's there for. But I'm hearing you say for scale and throughput, you want to do that work and get out of there as fast as you can. So sure, allocate the memory, allocate the least amount you can, but the second that you don't need it anymore, let it go.
Right. Exactly.
So that someone else can use it.
Right. Because even an ideal garbage collector struggles with large blob objects. It's especially under load because it's the most optimal time to get rid of that RAM under load when you have large objects is immediately. And so, the garbage collector is never going to be as optimal as doing it right now. Garbage collection is a performance optimization for small objects, but not for large ones. I guess that's the best way to sum it up.
That is a really good way to remind people that, it's a convenience. It's a friendly thing to have around. It's great when you're dealing with small amounts of memory and you want to not think about them. But if you're dealing with something that you know is megabytes, even though the garbage collector is your partner in that, ultimately, when you put in a using or you start using disposes appropriately, you're not just giving hints, but you're being really explicit about that memory management as much as you can, because you know more than the garbage collector at that point.
And it's really flying blind when it comes to unmanaged objects. It's very hard to inform the garbage collector about how much memory an unmanaged object's using and when it's best to dispose it and all that stuff. And with WPF, they did a much better job of that, but it's still difficult and still slightly flawed.
Yeah. Well, I think that was a big deal early on. When .NET came out, 2001, 2002, 3 in there, I remember that we were all talking about that relationship between the unmanaged code and the managed code. And it always came up. When you were in the .NET 1.1 kind of world, you were always remembering that I'm using a system dot whatever, but that's really a handle to some unmanaged code. Because there was this bridge between the managed world and the unmanaged world. And then now fast forward 10 years and there's so many convenience functions and so many easy ways and easy libraries to do work. I think that maybe newer people, younger people, people who are just getting into .NET forget that these unmanaged blobs that are kind of fronted by managed friendly libraries still exist, and that you really can't count on the garbage collector to know everything about that world.
Yeah, it seems like everybody, at least on Stack Overflow, they don't even realize it's unmanaged. It's this constant thing that's like every single time there's a question or post about managed.memory and system.drawing, there's these people arguing that the garbage collector is going to take care of it because it's handled, but it's not.
Well, and this actually brings up an interesting opportunity to pivot the conversation, because one of the other things I thought was great about your comments was that you point out kind of when managed code is appropriate and when it's not. And you say that IIS is way more efficient than ASP.NET at serving static files from the disk. And we should dig into that a little bit, because the blog post that I blogged about was trying to get people to turn off this feature called RAMFAR. RAMFAR is RAMMFAR, Run All Managed Modules for All Requests. And basically it's this feature that was turned on in order to enable early versions of ASP.NET MVC and routing, and it's no longer required. There's really just no good reason to do it. But the ramifications of running all managed modules, running managed code for every single request is huge, particularly around images and JavaScript and CSS, and you had a lot of good opinions about that.
Static files are a completely different problem scenario than logic and managed code. Static file serving is a highly competitive area because there's so many ways to do it. In an ideal scenario, you have one thread per virtual core on your server. And for serving files, you use an event loop because you don't need those threads, and thread switching is expensive. You can handle an unlimited number of requests if the number of requests doesn't matter.
Yep.
Because you're not allocating stuff for it. It's a queue. And you have no thread overhead, no switch overhead, nothing. It's just incredible. Now, IIS 7, IIS 6 and IIS 5, not so much, but IIS 7 is a really great server for static files when you don't have ASP.NET enabled. It's definitely competitive with anything else on the Windows platform. It uses the HTTP.sys kernel level code to do this. Doing it in user space is not real. You take a threefold hit, performance hit, if you try to, serve static files or any kind of files in user space. That's kind of the performance bottleneck on Windows there.
Well, and you've got kind of three levels there. I mean, I know that I did a lot of work teaching. You can basically teach HTTP.sys what you want it to do. You can make sure that kernel mode caching is on, and that means that a port can open up, a TCP connection can be connected, and you can have all that work happen in the kernel, and a file can be returned without hopping out into user space, and then from user space hopping into managed code. So you've got that threefold hit jumping out of the kernel, and then another couple of orders of magnitude to jump into managed code and serve a file from ASP.NET itself.
Exactly. And when you let MVC or ASP.NET serve a file, it can actually be worse than that because in addition to all those overheads, if it tries to serve it from managed code, it's going to allocate either a buffer or allocate for the entire file per user downloading the file. And that's what's important, because if you buffer the entire file into memory to serve it to a client, your scalability is gone. You can't scale that. I hate to get off topic here. Back in 2007, I was doing a content management system based on ASP.NET 2, and I was using virtual path providers. It turned out that back then, if there was any virtual path providers enabled, it would switch to managed code for serving static files. They fixed that. I I reached out to Scott Guthrie and Thomas, I think it's Marquardt. I can't pronounce his last name, but
Sure.
they rewrote the static file handler based on my request and got a really decent managed implementation of static file handler done, and also made it so that code path would only take effect on a virtual file, not if just anyone was registered. So it was much more efficient after that hotfix, and I believe that was included in .NET Service Pack 2.
Early on. This is a while back.
Right, but the net result of that problem was that there'd be a 100 megabyte MP3 file being served to the client, and after eight clients were downloading it, the server would crash at 8 because it was getting buffered into memory.
Mm-hmm.
And a 32-bit process, you don't have much room to work with, maybe about 1,200 megabytes. So
Right. Now, this is low-level stuff that we're talking about here, and we don't want to. I don't want to get people panicked about, like we're saying that you get this many times worse performance and this and that. This is less about ASP.NET being lousy at a particular task, as it is about, like, it's almost like comparing C# to assembler. What I'm saying,
totally
and I think what you're saying, is that there are tools for the job, and if you want to serve static files from a disk, you do that with IIS. You don't do that with ASP.NET.
Or you segment it. I'm really fond of making your static files and your dynamic files run on separate software. The easiest way to do that is with edge caching, because you can basically just have a reverse proxy over your static files, and then it doesn't matter that much. But ideally, you put your static files one place on software that's optimized for static files, and you put your dynamic requests, which is just your HTML and your XML, your AJAX stuff, that goes through a server that does just that. And that's the best out, and it doesn't matter if it's ASP.NET, Ruby on Rails, whatever the platform is. That's the best architecture, because your smarts server, your dynamic server, can be optimized for being dynamic and smart. Your static server can be optimized for doing that. Trying to do both on the same website, it's not possible. You can get a compromise, but it limits your optimization.
And segmenting like that seems like such an obvious thing, but you'd be surprised how few people do it. And it just has to do with just general segmenting.
It's rare.
A very, very brief but funny story from I want to say the late 90s. I was working at 800.com, and we came up with this. It was like Best Buy. They got bought by Best Buy, I think, actually, in the end. They had this deal where they said 3 DVDs for $1. And this ratio that we had been so comfortable with of 99% of people browsing and 1% of people checking out of our shopping cart changed. And it switched, and suddenly everyone had got their 3 DVDs, but they wanted to give us money, and our shopping cart implementation didn't scale. The whole application flipped on its side, and had we segmented it into browsing, which was read mostly, and purchasing, which was write mostly, we would have been fine, but we ended up having to segment it kind of on the fly. And that basic segmenting thing almost 15 years ago, it saved our butts, even though we had to do it on the fly. I'm surprised how few people do it. They'll put something in the cloud, but they won't have their images on their own DNS, and they won't have their images served by a CDN, and they won't segment the product catalog from the checkout process.
It's attractive for organization to have everything in one place, but it's possible to segment without destroying your organization. And basically, to do that, you really need a reverse proxy. And Microsoft has a reverse proxy in the form of IIS server. There's also Nginx, CloudFront's a reverse proxy. And
what about ARR,
caching
application request routing in IIS as a reverse proxy?
I've heard of that, but I haven't used it myself.
Well, maybe say something about what a reverse proxy is. I don't know if necessarily everyone is familiar with that concept.
A reverse proxy, probably everybody's familiar with a proxy, which is a caching proxy, is a proxy that will take local copies of commonly requested content like Microsoft.com, et cetera, and send it back so that usually the corporate internet connection doesn't get overloaded so much. A reverse proxy is a proxy that's right next to the application. It sits there, and everybody who tries to get to the application goes through it, and it caches what the application sends out. And so the application doesn't have to do the same work over and over again, and it can use HTTP level caching, because HTTP level caching is a lot more efficient and a lot more scalable than application level caching. You can load balance among a lot of edge caching solutions more easily, a lot of edge caching servers more easily. You're using HTTP stateless, a lot easier, and you can optimize for the HTTP protocol versus application-specific caching headers and stuff like that.
That's a really important thing to remember. I mean, people will do what they think is caching, which means they'll throw something into the ASP.NET cache object and put a little if not null check around it, and they'll say, all right, I've done my caching.
Yeah.
Now you're laughing. You're going to make our listeners feel bad. But I think the point is, as we talk about scaling, do as little as possible. And HTTP level caching is a way of, all the stuff like E tags and if last modified and all that stuff. That's all built into HTTP. And few people will take advantage of that and be smart about that. You just don't want to be serving anything that you don't have to.
And ASP.NET doesn't handle the HTTP protocol as well as an edge caching solution will. Like
as well, it probably
modified E tags, all that stuff. It's a lot of complexity, and so it's not there for a reason. But it's easy to add at the HTTP caching level, really easy. And so you don't need to accept ranges support and all this stuff. It can be handled by the cache. Solves a wide range of problems that you have when you're trying to communicate through MVC or web forms, whatever it is.
You bring up a really interesting point about HTTP handlers, and you talk about the ability to delegate work back into IIS. And this is really significant because I want people to understand the relationship between HTTP.sys, IIS, and ASP.NET as we move our way up farther into application code. But as you make those transitions, as you transition from IIS into ASP.NET, there's a brief opportunity for you to delegate work back to IIS. Can you talk about that?
Yes. It's not too brief, but it's really brief if you want to take advantage of authorization and authentication. After post-authorized request, you can't send work back to IIS because it's already marked for processing by the managed runtime. So, for example, even in begin request, you could call HTTP context.rewrite path, and you can, say, okay, I want this request to go here instead, and that's how URL rewriting is implemented. It's with rewrite path, and it's this invisible thing. It's not a redirect. It's invisible rewrite of that request that came into another path, another query string. However, if you want to, get authorization authentication for the original URL first, you have to do it in post-authorized request. Because that's after authentication's already happened, after authorization's already happened. And what that does is if you use that event handler, you can allow URL authorization to take effect to protect resources, and then rewrite the result to either the disk cached image without exposing private files to the internet. If you wait until the process request stage, which is where an action result executes, where an HTTP handler executes, anything implementing IHTTP handler, if you call that, you won't, the request is already being handled by ASP.NET. You can't send it back to IIS 7. And there's certain service packs in which it works and certain that it doesn't. But basically, in the latest version, it doesn't. So basically, you just can't do it, especially if you want to have a sane deployment scenario.
I mean, how much do you recommend that people look at that? I mean, should we be looking for optimizations where we can bail out of a managed module and delegate work back, or is that something that's more complicated than it's worth?
Basically, my advice is don't use routes for static content. Use URL rewriting. URL rewriting is way more powerful than ASP.NET routes, which is also why it's intimidating. But if you haven't already learned a little bit about regular expressions, they're a really powerful tool. There's something every developer needs to learn about sometime, and it's better to make the jump earlier than later, because if you wait like I did and learn them later, you'll go back and look at those thousands and thousands of lines of parsing code and replace them with a single line of regexes and hit yourself on the head with, a baseball bat or something for your own stupidity. Mm-hmm. Because it's really a really great time saver. I was there. I did that.
Yeah, exactly.
I've had entire programs that could have been handled by a couple lines of regular expressions. But URL rewriting will call rewrite path early enough to let IIS handle things. So the scenario in which you call rewrite path manually is like, for example, an image resizing.net project where you're doing disk caching. You have to do a little bit of processing to determine what file it goes to, which in our case is we build a hash of the modified data to source file, the URL, and the query string. We hash that, and that determines where the file gets cached. Now, hash is a pretty efficient operation, so there's very little time spent in managed space. But without that, there's no way to implement authorization or authentication and to support those, and that's important. Because all this stuff we talked about, reverse proxy, is great for public static content, but private static content is a more challenging problem, and that's where you need to do this kind of thing. Because there's no other, if your application is the only layer that has access to authentication and authorization information, it's the only layer in which you can implement caching for protected files.
Well, this is really, really useful information, and all of this is built up over your experience building your product, which is the imageresizing.net library, and you've got lots of good information up there that people can check out. And just to be clear to the listener, I reached out to Nathanael, and I'm talking about his product because I think it's amazing and awesome, and I've talked about it before on the blog. He's not an advertiser. This is just me, Scott, saying that this is a rocking awesome library. He's got a really, really great license for both open source and commercial, and you can even talk to Nathanael and have him look at your architecture for a very reasonable fee. And you can check out all of his content up at imageresizing.net, and we'll put that in the show notes as well. I really appreciate you sitting down and talking with me today, Nathanael. This is a huge topic. We could probably go for another couple of shows. We might want to do that in a couple of weeks and dig even deeper into maybe the cloud and web farms.
Yeah, it's a really, really big topic. It's hard to cover it quickly.
It sure is. Well, I appreciate the overview, and thanks for coming on the show.
Thank you, Scott. Appreciate it.
This has been another episode of Hansel Minutes, and we'll see you again next week.